And I'm very happy to introduce Will, who is an MVP in the data platform space and is joining us from New Zealand, where he is building a health platform on serverless tech.
Hey, guys. Awesome. Thanks very much for having me. Welcome, everyone, to Azure Serverless Conf. So good morning, good afternoon, good evening, wherever you are in the world. Thanks for joining us. My name is Will Velida. I'm an Azure integration consultant working for Datacom and a Microsoft Data Platform MVP based in Auckland, New Zealand. Now, in this session, I'm going to be showcasing a little side project that I've been working on, building my own health platform with some serverless technologies. So this is going to be a nice overview of several different serverless technologies that I've used to build my own platform, kind of like side project. And hopefully this will give you some ideas. Say if you've got a side project that you wanted to work on in your spare time, or you're thinking of a system to improve or make your life a little bit better. Hopefully this will give you a little bit of an inspiration. So to start right from the beginning, this year was a big year because I'm starting to get old. I turned the big 30, the big 30, and I kind of had this realization that I should probably look after myself a little bit more, start to think how am I getting enough exercise? Am I eating right? Am I sleeping properly? Am I doing a certain amount of steps a day? And prior to my 30th birthday, I have a bunch of Fitbit devices that I use day to day. So I've got a Fitbit watch, which tracks my activities, tracks my step count. I also wear it when I go to bed, so it tracks my sleep. I also have some Fitbit scales, which I can jump on just to track on my weight. And I also use the Fitbit app as well to log my food. So I have all this data just sitting there, not really doing much. I'm just collecting. It's just there harvesting my data. And I was thinking, well, how can I actually use this data to make some more informed decisions about my health? And how can I access this to actually do something useful to it, with it? So, so I did a little bit of investigation on how I can actually get this data, and it's available as an API. So Fitbit, the good people at Fitbit have developed an API, and I can actually call some endpoints to actually retrieve this data, which belongs to me and that I'm generating through my devices. So it got me thinking, how can I build an application that incorporates my Fitbit data and try and use some of the technologies that I know and love and try and build something meaningful and useful out of it? So I started with just a simple piece of paper, writing up some requirements. So I thought, well, I can actually call this API on a daily basis to get last night's sleep, what I ate the day before, what kind of activity I did the day prior. I can also use the API to call to actually get a month's worth of weight data. I don't always jump on the scale day to day, but I can do that over a period of a month. So I can use the API to do that. And then I had a look at the data that when you call the API, what kind of data gets returned to you. And there's some data that I'd want to use, some data that's not so useful. So I needed to have a bit of a process where I can actually call the raw data from the Fitbit API and transform that into a schema that I could work with and that give me the data that I could actually use. And then I need to take that transformed data and then persist it somewhere. And it needs to be really, really simple. It needs to be flexible because over time, I might find that some pieces of information are a little bit more useful. Maybe I'm retrieving data and not using data that could be useful. So I need a data base or a data store that provides me with that flexibility. And then I also need a way to, once that data is persisted, I actually need a way to actually serve that data via API so I can do some visualizations on it, maybe build a little website, maybe serve that data from the data store and feed that data into some machine learning workloads, etc. So what I came up with was the following architecture. So starting right from the Fitbit API, I can use timer functions to actually run functions on a schedule to call the API. So at 5 o'clock in the morning, my timer functions start, and they actually call the API to retrieve yesterday's data or monthly data for my weight data. I also have another function to refreshes my authentication with the Fitbit API, because for those of you who aren't so familiar with Fitbit APIs, you need a way to be able to authenticate to them. So I have another timer function that actually handles that authentication for me. So it will generate a new access token that I can use, and I store that in Key Vault. And then when I need to retrieve the data from Fitbit, I can essentially get that token from my Key Vault, so I can call the API and make authenticated calls to get that data. And then I need to handle the processing of messages from function to function. So I'm using Service Bus to enable to be able to do that. And then I have other functions that read messages from the Service Bus and do a little bit of mapping from its raw data into the new schema that I want to persist, and that persists to Azure Cosmos DB. And then sitting on top of that, I've got a bunch of serverless API functions that are essentially HTTP triggers that can actually serve that data from Cosmos DB. I've also got a logic app as well that every time an exception gets raised within one of my functions, that will send a message to a Service Bus queue. And essentially that logic app will pick up the message from the queue and then send an email to me. So I get a little email saying, hey, one of your functions, something's bad has happened in one of your functions. You should go and take a look at it. And then we've got a little bit of basic monitoring and CI/CD as well that kind of orchestrates this. So I've got application insights that monitor my functions. And I'll talk a little bit about how application insights works really, really well with Azure Functions. And then for CI/CD, I'm using GitHub to host my code, and then Azure DevOps to manage my build and releases. And I'll talk a little bit about how that's working within this project. So why Azure Functions? I really wanted to take a code-first approach. Another motivation for actually doing this project was to kind of work on my development skills, work on my coding skills. So I opted for Azure Functions, and Functions can help meet the demand with as many instances and resources as needed, only when needed. With this pipeline, I don't need my functions to be running all the time. There's literally some timer functions that wake up at 5 o'clock in the morning and actually make calls to the Fitbit API. And then once that's done, I don't need it to be running anymore. So Azure Functions provides a really flexible way for doing that for me. Now we can write our Azure Functions using any of our favorite programming languages. So we can write them in C# like I have. We can write our functions using Java, JavaScript, PowerShell, or Python. And if we're using other languages, maybe such as Go or Rust, we can write custom handlers to author our functions. I wanted a way to automate the deployments for my functions, both the function application infrastructure as well as my code. And also I needed monitoring as well. So when things go wrong, I want to know what's gone wrong. And Azure Functions integrates really, really well with monitoring tools that allows us to gain insights from our applications. Now, in order to react to events in functions, we use something called triggers. Now, triggers are what causes the functions to run. So a trigger defines how a function will be invoked, and each function actually must have exactly one trigger. And triggers will have associated data with them, which is often provided as the payload for the function. So in my application, I'm using mainly 3 trigger types. So I'm using a timer trigger, which essentially enable our functions to run on a schedule. We provide it with an n-cron tab expression, and that's when our functions will be invoked. And we're using that at a particular point in time to make a GET request to the Fitbit API to actually retrieve that data. I'm also using Service Bus as well, a Service Bus trigger type. So enabled to react to messages sent to queues and topics, we can create Azure Functions that have a Service Bus trigger to be able to process messages that are sent to our Service Bus queues and topics, which is what I'm doing within my kind of Fit Health platform. So whenever a message is sent to a Service Bus, I can actually read a message off the topic. And then we also have, I'm also using HTTP triggers. So essentially we can invoke our functions via HTTP requests, but we can also use HTTP triggers to respond to webhooks. And I'm using that with a bunch of serverless APIs that I've developed to make GET requests to actually retrieve the data that I've persisted into Azure Cosmos DB. Now, with functions, there's a huge amount of support for a variety of different triggers and also bindings as well. So this is a very small subset that I'm using. We can create functions that get invoked due to events happening in Event Hub. We can have Kafka support. There's really quite a lot of different variety of triggers that we can use within our applications. And there's also a lot of flexibility in how we host our functions. Now, in my scenario, things are only really happening. It's very low burst traffic that's actually happening within my function application. Really, it's only 5 o'clock or 6 o'clock in the morning. Something happens, and then for the rest of the day, they just sit there idly. And then for that, we can use a consumption plan. So we can only pay for our functions when they run. And there's automatic scaling, so they scale up to as many events as we need it to, and that's all handled for us. Now, depending on what kind of workloads you're going to be processing, there are a variety of different hosting plans that you can use for your Azure functions. We can go up to Premium, which is the next step up. So essentially, there are pre-warmed instances. With consumption plans, you can scale right down to 0 instances, but that can cause some latency through cold starts. In Premium, this is not the case. You can actually have pre-warmed instances, which will run applications with no delay after being idle for such a long time. It also runs on more powerful instances, and you can also connect it to virtual networks. And you can have a longer execution time with your functions than you would with consumption. You can also host your functions on dedicated plans. So if you have an app service plan, you're not really utilizing the underlying VM. You can actually deploy functions to it. And there you can have some predictive scaling and costs, and also utilize the VM if it's being a little bit underutilized. There are also more isolated plans, so you can either run your Azure functions on app service environment, which provides you with a fully isolated and dedicated environment for secure network access, or you can actually host your Azure functions on Kubernetes, either directly or on Azure Arc, which provides you an isolated environment for your functions, but running on Kubernetes. Now, that's not to say that Azure functions are the be-all and end-all as part of this platform. Some part of our workflows need to be straightforward. It's a little bit more simpler to develop some parts of the application using logic apps. So within my platform, like I said, I have a single logic app that essentially sends exception details from functions to me via email. This came about because I was really messing about with the SameGrid API in Azure Functions and trying to get it on an Outlook.com account, which is a little bit more frustrating and didn't quite work as well as I expected it to. And what Logic Apps provides is a large collection of connectors and actions that we can use so we can build highly scalable integration solutions, and we can connect to a variety of different systems, whether they be legacy or modern systems, really, really simply. And I'll show you how I actually used Logic App to process those exception messages and send them to me via email. Moving to our data store, Azure Cosmos DB. So Azure Cosmos DB comes with a serverless offering, and it lets you use your Azure Cosmos DB account in a consumption-based fashion, where you're only charged for the request units that you consume by your database operations and storage consumed by your data. So for those of you who aren't too familiar with Cosmos DB, before the serverless option, we would have provision throughput. So essentially, whether you're provisioning throughput at the database or container level, you would provision your throughput, allocating so many request units per hour. And regardless of whether you're performing operations against that or not, you were charged for using those request units. But the difference here with serverless, we don't actually have that. We're only charged for what we used, so there's no capacity planning required, and it can serve thousands of requests per second with no minimum charge, and again, no capacity planning required. There are some differences. So some of the limitations are With Azure Cosmos DB serverless, you can only have a single region. It's not possible to add additional Azure regions to a serverless account once you create it. And it's also not possible to enable the serverless link. So if you're using Azure Synapse to run some analytical workloads on top of your Cosmos DB data, you're not able to do that using Cosmos DB serverless. But one of the big appeals of using the serverless option for Cosmos DB, Cosmos DB serverless best fits scenarios where we expect intermittent and unpredictable traffic with long idle times. Like I said, I'm only really performing work in the morning. So this functions will get triggered at 5 a.m. in the morning, and I'll persist to the database around that time as well. And then for the rest of the time, there's nothing really going on. There are a couple of GET requests to retrieve the data out of Cosmos DB, but it doesn't really justify provisioning throughput on an hourly basis because it's not required, and it's also going to cost quite a bit. So if you're thinking about using, if you're tossing up between using serverless or just continuous provision throughput, if you're just getting started with Azure Cosmos DB, if you're running applications with bursty intermittent traffic that's really hard to forecast and it's quite low, the amount of traffic that's actually hitting your database, or even if you're just developing or testing or running prototype applications or running in production new applications where you're not quite sure where what the traffic will be like, I'd really recommend using Azure Cosmos DB serverless rather than opting for provision throughput. And what I'll do is I'll just step into pricing calculator. So essentially what I've got here, I've just set up a serverless, or just entered in a serverless database for Azure Cosmos DB. And then in Australia East, which is the Azure data centers closest to me, per 1 million requests, you get charged 43 cents New Zealand dollars. I do apologize. If you're not too, I don't know what the exchange rate is. But if I have a gigabyte of transactional storage, I would pay 87 cents a month based on the, if I was hitting a million per 1 million request units. However, if I switch this up to a standard provision throughput with a single region write, with Australia East, so I've got 400 request units per second for a 31-day period, I'm paying $41.40. I've also got storage costs as well, which is still relatively low, so it's 43 cents. But here I'm paying $41.83 per month, which doesn't really make sense. If your traffic is really idle, you're essentially just burning money on throughput that you don't need. So if you have an application that doesn't have a lot of traffic, I'd really recommend going with the serverless option. And then monitoring, we need a way to actually see what's going on with applications, just in case something bad happens or an exception is thrown. We need a way to be able to actually diagnose what's going on within our functions. And the really cool thing here is that Azure Application Insights, Azure Functions offers built-in integration with Application Insights to monitor our functions. So Application Insights will collect, log performance and error data, and then by automatically detecting performance anomalies, and you can use analytical tools, you can actually diagnose issues that occur within your function applications, and you can actually understand how your functions are being used, and you can actually see dependencies between your functions and various other components within your architecture, which I'll show you in a little bit. And this really helps us to continuously improve the performance and usability of our functions. And we can use Application Insights locally as well when we're doing development. So it's a really powerful way of getting insights into your Azure functions. And then we can also use our favorite CI/CD tools for our serverless applications. So for this particular project, I wanted to kind of boost up wanted an easy way to boost up my GitHub stats. So we can actually host our code on GitHub. And what I've done is I've also implemented my build and release pipelines on Azure DevOps. I didn't think of using GitHub Actions at the time, but you can do a bit of mix and match with GitHub and Azure DevOps. we can enable this using service connections. So I've actually created service connections to GitHub, to Azure, so I can actually incorporate my CI/CD process through Azure DevOps. And you can also use YAML multi-stage pipelines for your build and releases. And here I've also used Terraform to actually provision my infrastructure. For this, I've used classic release pipelines, but you can also achieve this using YAML pipelines as well. So that's a lot of slides. So what I'm going to do now is we're just going to go through a very quick tour of the application. I'm going to show you all these moving parts. So this is application insights. So essentially what I've got is I've got this single application insights namespace, and all of my functions are admitting logs to this central location. And what I've got here is an application map. So essentially, I've set this to the last 12 hours because this all happened early this morning. But essentially, what we can do with this is we can actually see at a very high level what our dependencies are between different components within our architecture. So I can see here, I've got my authentication service that refreshes my token, and that's interacting with my key vault, and also interacting with or making calls to the Fitbit API. And here, from here, we can actually investigate the performance of the calls. So this is a function. We can actually investigate a function within my function application. We can investigate the performance of that app there. We can also see any failed dependencies. I can see one there. And we can view this in logs if we want. But so that's so those are my functions at the high level. So what I'm going to do now is just go into my function code. So essentially for activity data, my weight data, my food data, etc., I've got a similar pattern going here. So starting off, we have a timer trigger function. This kicks off at 5:15 in the morning, New Zealand time. You can actually set the time zone as part of your set the time zone on your function application. And this makes a call to the Fitbit API and sends to this topic here. So this activity topic that I've got. And if any exception gets thrown, it gets sent to the exception queue. If I go into this function here, this is where my document gets created. So what it will do, it will read the message that's been sent from. It will read the message from the topic, essentially deserialize that into a schema that I've formatted or that I want to persist to the database, and then it will persist that activity document to my Cosmos DB account. And then finally, I've got a function here I've got a couple of functions here that can actually read the data from the database. So that's just a very high level from point A to point B, right from calling the Fitbit API, persisting it to my Cosmos DB account. So if I go back here into this, so this is my app service plan. So this will be a dynamic plan that I've got. I've got all my applications running on Linux. We can deploy our functions to either Windows or Linux. I've chosen Linux. And this is these are basically all the functions that are sitting within that application plan, or app service plan, sorry, which you can create using either Terraform or Bicep or ARM templates. I've opted for Terraform because I was using Terraform quite heavily, but you can also use Bicep as well. So here I'm just creating a dynamic Linux app service plan. And then I'm also provisioning my Azure Functions using Terraform as well. So I'm importing my app service plan. And then when we're actually creating our function application, we can say, oh, okay, deploy it to that particular app service plan that we've imported into our Terraform file. So if I just go back, so here's one of the functions that I've created. So we can see there's the app service plan that it's deployed to. If I go into my functions there, I can see I've got this single timer trigger function that I showed you earlier. And here We can see past invocations from the monitor here. And we can also run this query in application insights that we've connected this function to. My recommendation, if you have a bunch of different Azure functions, try and make them, well, use only one instance of application insights. And with this, we can configure deployment slots, check configuration. If you're using managed service identities, I haven't enabled it for this function. You can actually, oh, I have. You can actually use MSI to connect to different services in Azure. So this one is actually connecting to Key Vault. We can also configure availability tests. So essentially, this will just be like a URL health check that will ping every so often just to make sure that the function's healthy and ready to go. It looks like it's passed last one. I'm just looking at the time, make sure I don't overrun. But I've also got this serverless Cosmos DB account. So here, I'm petitioning by document ID. As you can see, I can't deploy other regions. It's part of this account. But I've also got the serverless capacity there. And we can incorporate some CI/CD with this.
Sorry, I'm going to have to just jump in there for a second, Will. This is really exciting. I'm loving the detail in the way that you set up application insights and the mapping and everything through it. But we are running a bit out of time. There's been a few questions that have come in, but unfortunately we're not going to have time to get to them today. But for those of you that have been asking the questions on the public chat, don't worry, we'll get to them and answer them back there for you. Just to finish off, Will, is there any closing remarks, or do you have any links to share with the audience?
Yeah, so for the code, I've got it all hosted on GitHub. So there's my GitHub account there. Just basically github.com/Will Velida. Just search for my health, and all those different repositories are essentially the code that I've got for this for the project. Also feel free to connect with me on Twitter as well. I am in New Zealand, so the time difference, I may be delayed in getting back to you. Just takeaways, hopefully in that kind of like that basic demo that I showed, that it basically with the serverless technologies, you can actually build something really simple, really straightforward, but add layers of sophistication as required. So it can be anything ranging from a simple like basic project from A to B, but you can also add layers of sophistication such as CI/CD monitoring and really scale up your application depending what you're trying to achieve.
Excellent. Sounds good. We've just got another short video and then we'll be back with our third speaker.